Now it's your turn to factor binomials that involve perfect squares. Stop this video, take a moment to write out your answers to these problems in your lecture outline packet, and then turn the video back on to check your answers. Recall that the difference of two squares formula for factoring says that a squared minus b squared is equal to the product of a minus b and a plus b. So looking at this first example, we have x squared minus 1, and we can see pretty quickly then that this will factor into x minus 1 and x plus 1. The second example is going to be a little bit more complicated. We have t squared plus 16, and this plus does not work with the formula that we have. So we actually have the sum of two squares here. And in general, the sum of two squares will be prime unless the terms have a common factor. So to look at why we can verify that this is prime, let's go back to that idea of taking t squared plus 0t plus 16. And if we're looking at factor pairs of positive 16, and we need the sum to be 0, we can see pretty quickly that this isn't going to work. So if we take 1 and 16, we're going to get a positive sum. If we take 2 and 8, we'll get a positive sum, and that will be positive 10. If we take 4 and 4, we're going to get a positive 8. If we try all the negatives, we just get negative sums. So what we see here is that this expression is prime. T squared plus 16 cannot be factored.